Um, Again, my name is Brandon Brown. I'm a 3D printing application engineer, and we're going to talk a little bit today about SolidWorks simulation and some of the things it can do for your product design workflow. Before we go ahead and get started, I also wanted to mention that we have Silvio Perez. He's a simulation product manager at Hawkridge Systems. And he'll be with me today as a panelist, helping to answer some of your guys' questions and talk about Hawkridge Systems a little bit. Before we go ahead and get started on the meat of the presentation, I wanted to tell you guys a little bit about me if you haven't met me before. I joined Hawkridge Systems this month in September when they acquired Quest Integration. Before that, I was a Quest employee for over 5 years, working as a additive manufacturing application engineer and on the SolidWorks side quite a bit. Before that, I got my Bachelor's of Science in Mechanical Engineering from Montana State University in 2017. It was somewhat heavily focused on analysis work, hence my interest in simulation. I have over 20 certifications with Formlabs, Markforged, and SolidWorks. And outside of work, I'm a pretty avid mountain biker and skier. So if you're in the Spokane Metro, you might run into me on the local trails or at one of the local ski resorts. So let's go ahead and get into it. In this presentation, we're going to be talking about some of the different simulation packages, namely Simulation Standard, Professional, and Premium, and some of the different features and capabilities they bring, and some of the reasons you might consider bringing them on board to help guide your analysis and design workflows. So to discuss this, I have proposed a small scenario. I also forgot to mention that if you have any questions, feel free to enter them into the questions box and Silvio will help answer those, or we will answer them at the end. So this scenario we've devised is a conveyor assembly. We're designing this conveyor assembly. It's powered by a motor shown in yellow, and it needs to resist loads on the rollers and a reaction torque at the motor from it running, and it's fixed at its 4 feet. So traditionally, we need to first analyze this design before we put it into production. We need to test it, etc. And we could do hand calculations and physical testing and prototyping, but we want to do as little of this as possible because this is very expensive and time consuming. And this is where SolidWorks simulation comes in. This can be used to really simplify the analysis of these components on this assembly. So let's go ahead and switch into SolidWorks here really fast, like so. It's actually pretty easy to access SolidWorks simulation. This is just the CAD area. All you need to do is just turn on the add-in, like so. It's just loading the results right now. We have some studies that we're going to go take a look at. And to actually start a new study to activate simulation, all we really need to do is either switch into the simulation tab and define a new study right here, or switch to a study we already have open. In this case, we're just going to switch to one we have open as shown. And again, it's built right into SolidWorks. We don't really have to access any external software or export our CAD data and set it up externally. It's built right in. It's also really easy to set up an analysis. So to define loads and constraints, all you need to do is either define a fixture or a load, as shown here. In this case, we've already defined them, so I'm just going to edit and show you what it looks like in here. For example, a fixture, we have a couple different constraints we can choose here. The more basic ones are like either it's fixed in all dimensions or you have a roller slider. And all you have to do is click or unclick things to fix them in place. Likewise with loads, we're going to leave that as it was. All we need to do is define the direction and type of load and select the entities we wanted to apply to. Once we're done with that, all we have to do is mesh and run our model. And for sake of time, I'm not going to do that live, but I have some results here for you that we can see. Pretty easy to do. It actually meshes and solves pretty quickly. We just load these and now we can view our stress, displacement, or a whole other host of other results like strain plots or directional stress plots, other types. In this case, we just have our von Mises stress. And we can see the minimum and maximum relatively easily and go from there and use this for design guidance. Again, we can also view our displacement, plots and define some other plots like our factor of safety plot here, so we can see what our factor of safety is across the model. And actually, I've got a little call out here for my minimum, which is, I think, acceptable in this scenario. Let's go ahead and go back here for a sec. So in addition to the FEA capabilities, while some of this comes with SOLIDWORKS Premium, you get a lot more with Standard, some additional capabilities in the static FEA area, as well as you get access to fatigue analysis. So this predicts the onset of fatigue failure after multiple loading cycles. I remember doing this by hand personally. This was definitely not the easiest thing in the world to do. This tool would be really, really nice to have. If I were doing this work. You also get access to Trend Tracker, which is a tool that allows you to track different parameters as you iterate in a simulation. For example, in this case, we have the mass of the assembly as we have iterated through the assemblies and modified the design and changed the different parameters associated with it, and run simulations. So that's another really useful tool you get with Simulation Standard. All in all, this is a great package if you have you have simpler problems to solve. It's great for first step analysis, like kind of a first step into analysis and iterating very quickly, and it really helps speed up your product design workflow. But what if you are interested or need a more detailed analysis, or would like to do a more detailed analysis? For instance, you wanted to analyze the vibrational behavior of this structure like we're going to here. It's got moving parts, so it would probably be wise, especially like cyclically moving parts, so it would probably be wise to investigate the natural frequencies of the structure and the associated mode shapes. And Simulation Professional, with its frequency analysis, allows you to do this. So we're going to go ahead and back into SOLIDWORKS here to see what that looks like. Again, this is all built directly into SOLIDWORKS. All I need to do is either define the study or switch to frequency here. It's just like defining the other study, except this time we actually don't need to apply any loads because we are just looking for the natural frequencies and mode shapes. All we need to do is define the fixtures and go ahead and hit solve. And again, I've already done this, so we have the results available. I'm going to go ahead and list the resonant frequencies. So again, just by simply clicking the 4 fixtures into place, meshing it and solving it, we have access to all of our associated natural frequencies and associated modes and mode shapes. So we can actually take a quick look at this right here for each of our associated natural frequencies. Like so. So this is I remember doing calculations for vibrations. This is definitely a lot faster and a lot more convenient than going through this by hand or in a traditional manner. So again, pretty powerful tool in my opinion. Let's go ahead and go back into our presentation here. In addition to the vibration and frequency analysis, you also get access to a couple other really great tools in SOLIDWORKS Simulation Professional. One of my favorites personally, I wanted to highlight this, is the optimization tools, particularly topology optimization. But you also get other optimization tools like design optimization. This allows you to optimize defined variables such as, say, CAD dimensions, material properties, load values, etc., to reach user-defined goals based on the design of experiments method. This is a great tool for doing more simplistic optimization. So if you need to do, say, adjust the cross section of a structural member to meet goals while minimizing mass, that's a great example. Or if you want to find out when something's going to fail at what load, that's a fantastic example. Topology optimization, on the other hand, is personally, again, this is one of my favorite tools because I do a lot of work in additive manufacturing, and this comes up a lot there. There's a lot of potential there, in my opinion. Topology optimization takes a shape, you give it kind of a working envelope, like and it will actually go through and remove material and generate an optimized shape for the constraints you define, whether that's a stress constraint, vibration constraint, or like even a mass removal constraint, or even a combination thereof. And really is nice for developing truly optimized and efficient parts and assemblies. Again, really cool tool, and it comes with Simulation Professional. Additionally, Simulation Professional includes thermal analysis capabilities, which allow you to understand the impact of thermal loads from conduction, convection, and radiation. You're able to solve steady state and transient thermal problems for temperature, temperature gradient, and heat flux. And additionally, this is really nice if you don't exactly know what your thermal loads are in the structural side. You can import these thermal results as thermal loads to static studies to further increase your analysis capabilities and further speed things up in your product development workflows. In addition to these tools, you also get access to submodeling. So submodeling allows you to intelligently analyze subregions of your model while taking into account global effects. So for example, if we wanted to pull out one of those rollers in the assembly we've been analyzing and analyze it in more detail, look at it in more detail while still considering global effects, we could do that. You get access to edge weld connectors, which predict required weld size according to American or European guidelines. It also just simplifies the analysis of welds in general, and analyzing welds in finite element analysis can be can be tricky in some cases. So this drastically speeds up and simplifies the process. You get access to buckling analysis, which is able to predict failure under compressive loading due to local instability. And you also get access to drop test, which allows you to analyze the effect of an impact on a part or assembly on, say, a target surface. This is like, for example, if you wanted to analyze whether or not a consumer electronic device like a phone or a tablet, how it would behave under impact, or another electronics enclosure hypothetically. You could do that with the drop test add-in. And then you also get access lastly to the pressure vessel design study, which calculates linearized stress from several static studies, which is key for safe pressure vessel design. It's based on section 8 of the pressure vessel and boiler code as well. So it's really just a nice, well-rounded solution for speeding up pressure vessel design as well. So we've gone through a few tools already and gone through a host of different capabilities, but in our case, we still need to evaluate this design. Namely, we need to evaluate its performance under dynamic conditions, such as a sudden impact, or investigate harmonic loads, or investigate the effect of random vibration on the structure and see how it's going to respond when it's dynamically loaded. So SOLIDWORKS Simulation Premium allows us to do this. Firstly, we're going to look at an impact. So we're going to use the time history dynamic feature or study, where what's going to happen is we know the time history of a load, or how it varies over time, or the time history of the phenomena that we're trying to model. And we can define that load. In this case, it's 1,000 pound force per roller that's onset in 5,000ths of a second, applied to each roller like before, and we can actually run this and view the results in the time domain, so the full set of transient results, and see the full structural response over the time domain that we defined, which in this case is 0.2 seconds. We've got the displacement on the left and the stress on the right. Additionally, we also have access to a harmonic analysis, which allows us to determine the peak amplitudes and stresses across a range of frequency inputs. In this case, we have a harmonic load that varies over the frequency domain as shown. Again, we're defining this in the frequency domain. And it's about the same as before, except we're just using this harmonic load instead. And in this case, we're viewing the results in the frequency domain. So as you step through those frequencies, and we can easily see which harmonic loads cause the most stress and the greatest displacement on the structure. And then lastly, for our analysis, we're going to take a look at random vibration. So this is used to analyze the effect of non-deterministic loads. So things that are very difficult to model, like loads generated in the wheel of a car when it's traveling on a rough road, or base accelerations generated by earthquakes, pressure generated by air turbulence, or pressure from sea waves or strong winds. In this case, we're actually defining a PSD, or power spectral density load, of 20 g squared per hertz. applied to our entire structure, and it's going to vary over the frequency domain as shown here in that graph in the preview window. When we do this, we actually generate root mean square RMS values of the results, the stress on the left and displacement on the right as shown, but we also have access to PSD values, and we can also graph results at specific locations versus the frequency values that are applied using the random vibration tool. So that about concludes our analysis of this scenario, but there are a couple other very capable tools I'd like to discuss in SOLIDWORKS Simulation Premium as well. Namely, one of them is nonlinear analysis. So nonlinear analysis allows you to analyze nonlinear materials. So materials like they don't really fit into FEA, that don't abide by linear static isotropic behavior and assumptions. So think like rubbers, elastomers, those types of materials. You can look at post-yield behavior. So for example, if you're able to define a stress strain curve for your material, you can actually import that into SOLIDWORKS for nonlinear analysis. For example, to look at what happens post-yield or post-deformation on a part, like say in a sheet metal forming operation like we have here. And we're also able to look at large deformations, particularly large deformations that we would not be able to analyze using the standard SOLIDWORKS simulation solvers. Additionally, and lastly, the last thing we're going to talk about is composite materials. So SOLIDWORKS Simulation Premium allows you to access composite materials. And this is not necessarily a standalone add-in. It's actually something you can incorporate into other studies and analyses. But it really just allows you to define composite materials and layups and predict the loads carried by each layer and predict failure with the Tsai-Wu and Tsai-Hill failure criteria. So we've gone over a very large variety of tools that are built directly into SOLIDWORKS that allow you to solve a pretty wide variety of problems that are relatively easy to access and use. Again, built directly into SOLIDWORKS, and there's no transferring data. There's no setting something up again, like say in a separate software package. It's all built in, and it's all very capable. And this really allows you to develop better products faster because you don't have to do as much physical prototyping or testing. There's less resources involved overall. It's just kind of you and your computer or your team, and you can test far more rigorously with simulation because again, you don't have to do any physical testing. You can just kind of sit there and iterate and redesign and test, especially at early stages, which results in better products. So if you're interested in getting into simulation or increasing your usage or implementing the more advanced capabilities seen in like simulation professional or even premium, it is important to, even though these tools are relatively easy to use, it is important to learn how to use them properly and have somebody to help you along the way. And that's why I actually have Silvio here today to talk to you a little bit about some of Hawkridge's resources with SOLIDWORKS simulation and analysis in general. They have a lot of experience with this, and personally, I'm really excited to be working with them, and they can help you implement these tools pretty effectively. So I'll turn it over to Silvio here.
Great, thanks, Brandon. Hello, everyone. Again, my name is Silvio Perez. I'm the Simulation Product Manager at Hawkridge Systems. I just want to really just introduce, now that Hawkridge acquired Quest, I just really want to introduce what our customers gain and the Quest customers gain from now that acquisition now being under the Hawkridge Systems VAR family. And ultimately is that we've been in the game for 20 years now, 20 plus years now, and we have a variety of different resources. We have a large engineering team that really is capable with these tools, not only just SOLIDWORKS CAD, but all the other tools that we introduce under our portfolio, and simulation being one of them, right? We have, but when we narrow down the scope a little bit in terms of the simulation tools, we have 7+ tools available, and even in more advanced analysis tools that are outside of what Brandon just mentioned today. For example, we have Simulia Abacus that allows you to do a little bit more advanced nonlinear capabilities and some dynamic capabilities as well, more at an analyst level. So we really have knowledge in terms of, depending on what category you fall in, we can make the best recommendation for you. And ultimately, you're being helped, your simulation team You're being helped by degreed engineers that consist of mechanical and aerospace engineering. We have 40 plus years combined experience utilizing these tools. For example, I've been at Hawk Ridge now close to 10 years and really focused in on the SolidWorks and simulation tools. So I have a lot of experience and well versed within the FEA and CFD analysis tools where we can provide that type of help for you. We've helped 1,000+ customers on a training level, on a consulting level, on a mentoring level. So we definitely have the expertise to really get you going within these tool sets here. And that's kind of introducing one of the other things that we offer here at Hawk Ridge is being able to do consulting projects for you. So if you can go to the next slide there. We have a ton of different resources that relate to SolidWorks simulation and SolidWorks in general and all the associated tools. But if we focus on a little bit on simulation, we have a YouTube channel that I'm actually going to paste into the chat here that you can get access to. So it's available for you guys there. And that's our free resources of a ton of videos that we've created throughout the years. You'll probably find a few of them under me. But it's definitely a great resource there to get more information and get help on your simulation studies or SolidWorks altogether. We, of course, have a technical support. Again, this is staffed by degreed engineers who can speak the language, who are more generally mechanical engineers, but just have an engineering background and are there to help you out and guide you with these tools and really, get you to the next level in terms of helping you out and utilizing the tool. And of course, like Brandon mentioned, we also have dedicated training for these with these software tools as well. For anything that we offer, we have a full training course where it's fully engaged with an instructor, very similar to this environment here. Before the pandemic, this was in person, but now we've been doing it online, so have a lot of resources in that regard. But then again, giving you mentoring and consulting services opportunities where we can give you over-the-shoulder help, where if you have adopted the simulation tool and you've taken the training class, but you still need some extra guidance, we can offer you some mentoring, some one-on-one mentoring, in addition to where if you just want us to do the work for you, we can provide that service for you on a paid basis. Okay. But a couple more things here before we kind of let you go there. I do want to introduce, now being under the Hawk Ridge environment, we do offer these online events or these virtual events now that COVID is in place. But I wanted to introduce the Design and Manufacturing Digital Conference. It is free for our customers here. All you have to do is just sign up, so you get the invite link so that you can log into these sessions. There's going to be 18 live interactive training sessions, and again, it's not just a tutorial of like what these software things do. It's more of like a training basis. So there's definitely some good sessions there that fall from SolidWorks to 3D printing to simulation to some of the other products that we have within our portfolio here. So I just want to, kind of, or just look out for that chat again, where I'm going to send you this this registration link. You can move to the next slide there. But for your convenience, you can take a picture of your screen here for the Digital Manufacturing Conference. That QR code will take you straight to the link as well. But again, feel free to register. It's definitely free for you guys. You don't have to do anything. You just have to, make sure that you're available to do so on that end. But just wanted to introduce those concepts there. Really appreciate your time. Is there another slide there after this?
Yep,
oh, and then again for the for the YouTube channel, if you want to take a picture of that, that'll take you straight to that link as well that I posted in the chat. And feel free to subscribe. We're constantly uploading different videos where you can get an alert once we do that. Okay, so definitely check that out now that you kind of have access to that. Okay, well, I think that was all I really had to say.
Yep, I just wanted to thank you guys again for coming to this webinar and listening to us today. If you have any questions, feel free to post them in the chat now, and we'll answer them. And if you have any other questions after this, you think of something, feel free to reach out to us. at the email address, so hawk@hawkridgesystems.com, or call these numbers. You can additionally still reach out to us at Quest, and we'll go from there. Thank you for coming, guys.